I'm Phu Hoang Office. It's Rachely Rotem Studio. We work a little bit differently in that the two projects we're going to present tonight are collaborations between our two practices. We do a fair amount of work together, as well as work separately, and we like to believe that somehow this form of collaboration makes a new economy out of what is obviously a lot of inefficiencies. Exhale was the first project I want to show. So this project here is, it was designed from the outset. When we do our temporary environments, we design it for temporary conceptually. So it was built in 10 days, and it was up for 5. 7 miles of rope were hung up in those 10 days. Each one of those steel rings weighed about 5,000 pounds. And it was the public face for the 2010 Art Basel Miami Beach Contemporary Art Fair. It's the largest art fair in the US. And this is the event itself is called Oceanfront Nights. Each night they would have free public programming. It's basically Art Basel's public face to Miami. While all during the day, all of the events occurred in the convention center, the galleries. So to them, it was a very important way to present themselves within the city for the kind of brief moment that they're there. The rope volumes changed with the wind. Sometimes gently swaying. Sometimes a really kind of wild forms would come from the rope. As you can see, the programming events change as well. So for us, weather is a really important way to think about our work, our temporary work, is taking the temporary and making it, thinking about temporal weather events and programming. So this idea that these temporary environments, for us, when we design them, we see them as a kind of form of design research. It's ideas that we've thought about in larger scale theoretical projects. We test them out in smaller built environments, and the idea is that they get brought back eventually to larger scale projects. They all, in some way, have to do with how you can experience temporality in architecture through weather as an interactive experience. This project was, from the beginning, we knew that there were, for the site you can kind of see in the foreground there, it's the front sandy site. It's a beachfront site in Miami, which we were building the project during the strictest hurricane code time. Basically, Dade County hurricane code is 90-mile-per-hour winds. So from the beginning, we thought about, and we were working with Arab Structural for this, we were thinking about how do you design something for these conditions without dealing with the wind as just like a kind of necessary evil, to actually build it into the project. So the rope allowed us to not have to deal with the extreme wind conditions as much, as well let us give us a medium in which we could interact with the wind. So for us, this kind of interest that we have with weather and obviously with environment, it's more than what I guess you would call environmental design. We want to think of it as the design of environments, that we're actually creating weather experiences that are interactive in some way. So the question with the project and with a lot of the work is, how do you design for this kind of temporary, unpredictable forces such as weather? The rope, from the beginning, we worked out a system which was a weaving of 2 different ropes, which allowed both for movements to occur, because they're always in catenary, but also allowed for a kind of constraining so that you wouldn't get the kind of bundled mass of knots. So the wind speeds that you can see on the left, those are wind charts from each day from the event itself, the 4 nights of the event, and they varied widely and it came from different directions. The way that we tried to make this an interactive experience is that we worked on a technology that would allow the wind speeds to be translated into a digital lighting control system. So as the wind would reach certain levels, first it would go to one level and the site would go all blue. But it only be blue as long as it's at that wind speed level. So it's kind of like a blink, almost you could blink and it would be gone. And then next wind speed level would be green. And it was a very momentary thing, which we liked, that, like it's almost as if you could miss it if you didn't pay attention. And this, we had initially thought we would put the wind speed sensor up on top of one of the, what we call the structural tripods. In the end, it worked better on top of a palm tree, which was actually much better to imagine that somewhere up there we missed a wind speed sensor. That was what we called the environmental interactivity, the site interactions. There's this image is a kind of smaller installation called floating ropes, where the special phosphorescent ropes were hung in such a way where if you went up to a smaller wind speed sensor and blew into the sensor, it would trigger a set of lights that were ultraviolet lights, making the ropes kind of glow. So when you walk away, it would start to get dark again and glow when someone blows on it. This was the general effect of that. And we worked with, for both of those things, we were working with our AV consultant. We find that often we're having to kind of figure things out on the go and develop develop innovations with the existing technologies. There's no way right now that existing to make wind speed sensors communicate with digital lighting control systems. So that's something we worked on for a while to get that to work. And for us, the whole kind of project was about this, what we like to think of as like kind of high-low tech, which is that there are obviously digital technologies, but also they're paired with analog ones. So the rope is actually quite simple. And we spent a very long time working on the rope, which was is actually just a nautical rope. It's a rope from Coast Guard use. And we worked with the manufacturers to develop a specialized rope that was fireproof for building code, as well as had a large amount of reflective tracers that were built into it and sewn into the sleeve of the rope. The end result for us was actually really we were very happy with it because it looked a lot more expensive than it was. The rope, a lot of people thought was LED and that it was like a very expensive installation, but in actuality it was just 50 cents a linear foot kind of Coast Guard rope. That when the wind would move the rope, because they had the reflective traces into it, it actually would start to flicker, almost like a video screen. And then when it's out of the direction of the where you're viewing it behind the light, it would change its quality. So we really liked how that came about.
So you can see our strategy was of a canopy made of network of 7 miles of light rope. But in terms of structure, we had to deal with domino effect and possible hurricane conditions. So the structure is very massive. But in terms of the network for us, it allowed for a network of canopy, but almost completely open 25,000 square feet of open plan, which allows a lot of flexibility and kind of spontaneous interaction and spontaneous occurrences to happen. Besides the amazing weather we had, no signs of hurricane, thank God. You can see his construction photos, one important detail, which is this one, which is basically steel clips where each end of the rope had kind of mountain clipping hooks, and with one hand, anyone can basically kind of connect the rope to those clips. And one very exciting and detail that we had, but it was very important in terms of temporal pavilions, is we had a precast concrete footings that we did not anchor to the underground. They were sitting on top of the sand because as a temporary environment, you have to bring back the site as it was before. We designed 4 types of weaving for each rope, yellow and white, and then he created a variety of different options on site. Everything was pre-cut with a very short construction time that we had. And of course, when you're trying mock-ups in the factories, there's no problems at all. But when you move to a real site, the sheer quantity of 7 miles of rope became challenging and detected a steep learning curve from workers who don't really use this material on their daily life. So you can see here the different kind of the clumsiness of the ropes during construction, and coming from a different discipline, weaving and scale. It was challenging but also exciting to see the creativity of different tools that have been created and so on. Luckily, it was all built by the end of the last day, and this is kind of an example of the weaving. In terms of the open plan that I mentioned before, these are 2 scenarios for 2 days, where for us, except for the structural knots that we showed before and a specific space for hammocks, everything else was movable. We did not design one stage, we designed mobile stages where artists can basically very easily move it, put the equipment on it, and decide what space they want to perform in. Each night, different artists decided on different location. Everything was lightweight in terms of chairs and stools, so people basically followed the artists or creating their own interactions with their own group. And when you have such a big site, 25,000 square feet, which was a good strategy in our part to be able to allow for good circulation and change during each night. Creative time were the curators of this event, and they brought collaborators from different cities for every night. And you can see here we experienced different live shows, the DJs, with my favorite live DJ from Berlin, to lectures, and to dance performance, which we were really excited about. For this dance performance, they decided that the whole site is their stage, and people basically follow them around, which we really, it felt like it engaged very well with the architecture. Recycling is part of our, we see it as a part of our professional obligations. Rope was donated for sailing clubs, for kids. Steel was reused. And what we were very excited about is we donated all of the footings were donated to become an artificial reef marine and the offshores of Florida. And it gave the project a new dimension of time and a new client, which didn't pay much, but we really tried to use different strategies to assist them to grow the reef, such as different textures that we allowed when they precast the concrete, and holes for electricity becomes like hiding areas for the fish. I will show in a more briefly manner a project that we're planning to execute in the summer of 2013. Chief to Boston was the organizer of the competition. It's going to be located in Boston in the Fort Point Channel on a barge, and the competition brief was basically create an interactive public environment, which we of course allowed the challenge of it. As Phu mentioned, we are always testing in different scales, both in material and large concept, things in the office before we execute them and propose them. And we were at the time very interested in the concept of camouflage. For us, camouflage, both form and as in terms of environmental qualities that we'll mention later, has a lot of interest to us. Camouflage makes familiar objects look strange and strange objects look familiar, and we like its duality. And in terms of the urban context, we wanted to create some sort of a temporary icon, but also a disturbing one. That's why it's also pink. Basically, the project is comprised from a ground floor activity, which is kind of a temporary gym, which the energy that is being generated by pedaling is used to, in different ways, to activate this kind of cloud, which we call the camel vapor. It is made of three-dimensional camouflage net held by weather balloons filled with helium. Because it's balloons, they're never exactly, they're not completely anchored. They have some sort of movements that we allow it. And so basically the whole form change with the winds. In terms of programs, nighttime and daytime are completely different. Daytime, we collaborate with the Boston Children's Museum, and it's more family-oriented. Basically, in terms of the bags, again, it's basically generating energy by paddling, storing it in DC batteries, and then we can use this energy to activate the cloud. What's nice about it is the more you paddle, the more energy you get, the more people are there. It basically changed the environment that we create. This is a night scene that basically the crowd is different. This is a collaboration with one of the hotels around it to become some sort of a lounge area for people from the hotel.
So for the interactivity with weather on this project, we worked back in the competition phase. We were working with Trend Solar, the climate engineering consultancy, and we had decided that what we were trying to do is determine the ideal conditions. So we actually, when we had won the competition, told the client what the best time would be, and through there's a series of factors, but basically the more important ones are relative humidity, which you need a low relative humidity in order to make evaporation or evaporative cooling work, and the prevailing wind conditions, which are obviously an issue when you have weather balloons that you're trying not to lose. So in the end, it looks like August and September are the ideal months for the project. The idea is that we're creating microclimates, and as Rachely mentioned, the more that you bike, the cooler you get. So hopefully it makes people bike more and more. The way that the system works, we're developing this technology with the mechatronics department at the University of Pennsylvania, where basically the bicycles, the pedal power is converted and brought into a system that would vaporize the water. The water goes into this camel vapor, and it gets held onto the surface, and the idea is that the wind from the harbor would pick up the water, bringing it into the air, creating a kind of cooling island, just where the area is. This camouflage net, this three-dimensional camouflage net is supposed to simulate foliage. Interesting thing about it is it's pink because deers cannot see the color, but hunters can see each other with it. The material itself offers a possibility where we're going to control how much is perforated, so that the more planar surfaces are water can shed more, thus controlling the humidity. We also have an idea about integrating air plants into it, which live off, which are sustained from the humidity, and that they would be kind of woven into the fabric itself. As with Exhale, the previous project, we like to think that we're not designing any single image. We're not trying to design for fixed outcomes, but actually more possible scenarios. So we don't really totally know at this point what it will look like. This is kind of what we guess it will look like. And the idea is the project changes form. The weather balloons will move, obviously, with wind conditions. Also, the helium in them reacts to sun, and basically the balloons should raise and lower during day and night. So we're hoping that would happen as well. And I mean, for us, all these temporary conditions and weather forces allow us to test the idea of architecture that would interact with weather, as well as the public interacting with this kind of architecture. Thank you. Okay.
Can you say the biking, sorry, or make it clear?
Okay. So the bikes basically are stationary bikes, and people would pedal the bikes. The energy from that pedaling would get stored into a battery system. That battery system would then be used to vaporize water, which those vertical pipes are water pipes, and then the water would go up into the tank system and be held within this fabric. Because it's kind of like has a lot of surface area, the fabric can hold it for a while as the winds.
Yeah.